Welcome to another episode of the Data Sense podcast. This is the podcast where you learn from technical and business leaders how to connect your business and data to develop your own sense to drive your business forward. Today, we have Michele Sollecito as our guest. Michele is a software product delivery executive from an architecture and JVM background, JVM meaning Java Virtual Machine. He's still hands-on and writes code pretty much every day, but currently he focuses on building effective processes, teams, and departments. Michele's main work interest includes system thinking, agile, and event-driven architectures. Thank you so much for coming on the show today.
Hey Zane, how are you? Well, thanks for having me, first and foremost, and yeah, looking forward for our chat.
Awesome. Tell us what's your interest in software? What drove you to become a software engineer, and where you are currently?
I mean, I currently work for JP Morgan Chase in the UK, and funny enough, I actually started being a software engineer a little bit by mistake. So the idea is I got like my degree in robotics, like control engineering. And then, Italy being Italy, there wasn't like too many job opportunities. And so, I started working as a software developer and never looked back. The thing that's amazing to me in the space is the amount of freedom and creativity that you can actually use to like implement a solution. And it's very different from other engineering fields where basically like most of it is codified and you just need to optimize and fine tune. So it's more to a craft to an extent.
Yeah, I agree. I'm also, I guess, a software engineer by mistake. The thing is that I basically studied maths and physics at university, and I basically realized that maths is too abstract, and I realized that I actually like software more. And that's how I sort of just got into it. Like, oh yeah, software is what I like more.
Yes, it's good, man. I mean, like, I totally agree. I did a lot of maths as well and physics. I mean, obviously not to the same level, but yeah, totally
Yeah.
agree.
So with that, what would you say? You mentioned something about you were first into robotics and then you got into software, and because it was more to do with you found more freedom. Is it because it's easier to experiment with software, because obviously with software it's much easier to prototype, whereas robotics you need like a whole set of robots around.
Yeah, I mean, that's definitely one of the reasons is that the speed of feedback loop is super important. It determines so many things, and we can probably talk about it later when we talk about, designing processes and teams and so on. But basically, like, yeah, definitely in software, the cost of change is so much lower than in anything that involves hardware and so on. But also software is a lot like more recent as a branch of, knowledge. And if you go into things like mechanics and things like that, well, we've been studying this stuff for a while. And so it's quite unlikely that when you need to build, I don't know, a bridge, you will take a completely from scratch approach. Most of the times, you start from the shoulders of giants and just need to fine tune a couple of things.
Unfortunately, you can't just import bridge from. Import bridge from giants and maybe bridge dot connect, but at least in software that's exactly what you do. So cool. Okay. And so how you have been a software engineer, and now you're obviously a very senior software engineer going into system thinking and agile, and looking into how you could optimize processes and stuff. What are your opinions, or what I would say is, what do you advocate in software? Where is the world going? What is one thing you would like to see as as an architect? You're like, I've seen a lot of buildings now. What is it that you would say, this would really improve?
Mhm. Yeah, I think like the two things I'm about to say are related, right? And most of my concerns about the industry these days is not even just from a tech point of view. It's it's about the way people work together, or to better put it, how they not work together. So in the average company, and it's pretty sad, they're always talking about teams and teamwork, but it's mostly just like empty talk. And what happens is there is this image of the individual contributor. I know we're talking about individual contributors and the individual contributor career ladder. And, we split tasks into individual assignments, and people work on feature branches in what I like to call, I mean, it's hardly my term. I think it was Dave Farley or somebody else who named it like that. But basically, it was like this
Mm.
process called continuous isolation, right? Where the idea is I work by myself, I open a pull request, and some people have a look at it, and then it gets merged and rinse and repeat. I pick my next task and do it again, right? And to an extent, this can work, but it's both very boring and also not that effective, right? And I personally believe that software
Mm.
development, like a branch of engineering, is a team activity, right? And so when it works best is when
Mm.
you mix in people with different strengths and have them work together on the same whole
Mm.
problem every day, right? Not like saying that if you're good at data, you do the data part, and if I'm good at backend, I do the backend part, because that also creates a ton of like social problems, blaming, and you can win if I lose, and the other way around. And it's so much better to just mix in experts and let them self-organize into groups and work together, right? So I'm a big fan of things like ensemble programming and work on trunk and all these
Mm.
kind of methodologies, and we can discuss in a second. But yeah, so this is, I think, is the biggest concern I have, which is the average company have
In terrible
developers work
ways.
in terrible ways, and then yeah, exactly. That's what I mean, right? And so there are so many problems that come out of this, right? Because as an example, if you take data engineers, right? Typically there is a data engineering department, right? And what they
Mm.
do is they work just data engineers with data engineers, which sounds great if you're optimizing for efficiency, but there are some devastating consequences. Like as an example, when backend engineers just work with backend engineers, they will take some
Mm.
decisions without being informed by the data engineers, and this will have consequences on both backend and data, right? And then the point is, when I change
Yeah.
something, you might
Yeah.
not
So
know
what
about it,
you're saying
right?
is
On
that
the other side of the world.
um, what's happening is that engineers or backend engineers are working in a team of backend engineers. Data engineers are working in a team of data engineers. They're not talking to each other,
Yes.
and they're definitely not talking to the front end engineers. Definitely not talking to the data scientists, and they're being very
Yeah.
independent of each other. Yeah,
Yeah.
I can, yeah, I can relate to that. I can.
Exactly.
The thing is that I agree with that, where there's that that at least what happens. The funny thing that happens is that first you don't have like a structure where you agree on particular principles on how the whole
Hmm.
code should be written, right? The If it's backend, uh,
Hmm.
it you have to think of how we can um, I guess create some sort of a structure where everything follows that structure. Everything follows a principle.
Hmm.
And if the backend engineers do have that, which they normally do, the data engineers will have a slightly different one. And that's
Hmm.
probably due to they are
Exactly.
sort of inheriting from the data engineering background. They're trying to take care of the data, and they're saying, well, our principles are derived from data engineering side, and backend engineers are saying, well, ours are derived from the backend engineering side, but they're not sort of merging the two principles together to sort of
Yeah.
come up with. Yeah, that's pretty interesting. You know what's really bad? I think the data engineers and backend engineers not working together, that's one thing. What's even worse is when data scientists are not working on with them, because data scientists are coming from a very academic background.
Hmm.
They don't have the same sort of software engineering standards, right? They don't know, and if they're not integrated well into the rhythm of how you produce a software, regular releases, sprint demos, and source control and all these things. The issue is that they will independently do things, and they're like, yeah, we got this model, it's like 99% accurate, but deploying, well, good luck with that. Yeah.
Yeah, or testing it, or yeah, absolutely. Yeah, from my perspective, the way I'm used to work these days and the way I strongly advocate other people to
Hmm.
work is to create cross-functional teams that own problems end to end. And another one that I see, and what I'm about to say is a little bit controversial, because there's a lot of companies that don't do what I'm about to say. You see these, even people that do cross-functional teams, which often just means backend, front-end, mobile, data and DevOps. These companies which have DevOps teams, a little bit funny, but anyway, they're not usually part of these cross-functional teams, which is already problematic. But the point is, even when they do create cross-functional teams, they didn't tend to give these teams a domain, right? And so that like, oh, you're the, I don't know, customer onboarding team, and these other guys might be the trading team, right? But then the problem is overall this doesn't work that well, and for the same reasons, right? Because software systems are systems, right? And so their performance basically depends on how it's not like the sum of the parts, it's more like the product of their interactions. And what that means is that if I design the trading system and you design the
Hmm.
customer acquisition stuff, good chances are that they're not going to work well together, right? And the other thing is that usually bugs or problems, they derive from lack of understanding. And so if we silo things and now you don't have an understanding of how the trading system work and I don't have an understanding of how the customer acquisition stuff works, when I'm doing something on my side, I might create problems on your side or the other way around. And another big problem is that reality doesn't care about these artificial divisions. So, as an example, typically problems are cross-cutting, right? And so, as an example, it might be that in
Yeah.
isolation your component works, and in isolation mine works, but then when put together, they don't. And a much better model in my mind is to have basically a queue of things to do, like product initiatives or technical initiatives, and then I have teams that are cross-functional and equivalent, and they can just work on everything that's needed. And this also gives you the ability of focusing your effort, right? Because if suddenly all I do is trading, well, good chances are that all I can do is trading and nobody else can do trading. And so if tomorrow we need to work, I don't know, there's
Yeah.
a huge amount of work on trading, well, then gonna scale because the other teams can't help. While suddenly, if we all work on
Right.
everything
So
over
in
time
in that, what
as
would you
teams,
say
everything.
how they should be working? Is it, what would you say? Is it
Mhm,
should they be engineering something together so that they there is a sort
mhm.
of overlap between two different apps produced, or two different data streams, or just two different sort of like it could be two different apps within the same company, or it could be that one is a sort of a slightly
Mhm.
an external app, and then one is internal facing. What would you say?
So
How
usually,
should it be done? Yeah.
the model I have in mind is where the entire software product delivery department owns
Yeah.
the entire set of products and code base. And so the idea is there is no ownership. And so, as an example, if a team breaks something, doesn't mean that it has to be that team that fixes it, right? And it sounds like, oh, but if you remove ownership, people won't have accountability,
Yeah.
which is not what actually happens in reality, funny enough. And it's more like the opposite, right? And the way I see it working is you would have product people that stay on a value stream, right? So, as an example, you can see is they will have clarify the priorities within trading in terms of roadmap, but then the entire product organization needs to crunch all these different backlogs into a single priority queue. And then the teams simply pick up from the top of the queue. And as an example, if the initiative is to improve our trading engine, then they will go and work side by side with the trading product manager and trading expert for the duration until the entire initiative is done, whatever that means, and then do it again. And if the next initiative is now about customer onboarding, then they will go and speak with customer onboarding product person and so on.
Hmm. Cool. That's quite interesting. And with so the thing is that large companies can do that. Small companies obviously they have lack of resources and lack of sometimes talent as well. So that's one thing I can see where
You
it
think
would
so?
probably be
Because I
difficult
think this
for a
actually
smaller
can work
team.
even better for a small
Um,
company, right? Because this can work with even just one team. As in, you have one team, and one team works on everything. So,
right. Yeah. So yeah, that is true. The yeah, that makes sense. But suppose with sometimes what happens is they are working on. I think in a perfect scenario, yes, it would work. But I can just see so many problems that, for example, certain small companies may have one solution in
Mhm,
say Java, right? Another solution in Python, another one
mhm.
which was really old, which never touched.
Yeah.
You know, VB6, it could be in VB6, uh, and
Hmm.
then they have different teams just to focus on different sort of like
Hmm.
parts of the code base. And one thing is that they first have to sort of bring it into as much as
Hmm.
possible into a single sort of code base, where if they can keep it everything in Java or
But I
everything
think,
in Python, then let's do that. And then if they,
yeah, I mean, I get what you
what do you
mean,
say about
right?
that?
Which is, if you maintain everything, you need to understand everything, which is fair enough. I think there are a couple of considerations, right? So if you have cross-functional teams, by definition, you will have to
Yep.
understand the full stack. So what that means is that the very minimum you're looking at something JavaScript or TypeScript, something Android and iOS. Most likely, in most companies, you will see Go for infrastructure. Maybe that's Python for data and whatever thing you use for backend Java or not. So at the very minimum, you're already quite involved, right? And the other aspects are a couple of things.
Mm,
One is that when I say that teams do things, I mean it in a way where the teams are the unit of work allocation. So it doesn't mean that as an engineer, you need to understand everything and do everything and be an expert at everything because it's simply not going to happen. But as a team working together with, as an example, ensemble programming is much easier because you have experts in each of the things you need, and so you never work alone on something. On the other hand, the other aspect is I tend to value engineers not for what they know, but for the speed at which they can
mm,
pick up and drop things. And so it's
right.
exactly the point, right? The point is, well, if tomorrow we need to, I don't know, learn Redis because we think it's useful to do something, whether you know it or not is kind of irrelevant. You can pick it up very quickly, if you get what I
Yeah.
mean.
Yeah. That makes sense. But suppose that in a large company. So I think I have a really interesting sort of case study. Dropbox tried to do something similar, where what they did was they said for our
Mm-hmm.
Android and iPhone app, what we'll do is we'll have a single code base in C++.
Mm-hmm.
Now that's awkward, right? Because what they're trying to do is they're saying, well, you know, the iOS development is done in
Mm-hmm.
Objective C, which you know comes from
Mm-hmm.
C++, and Android is done in Java, or it was at least, and Java is also inspired by C++. So you could sort of have some sort of you know a single code base, and then the engineers started to quit, and then they were
Mm-hmm.
not happy, and then all these things happened where they just wanted to quit because they did not want
Yeah.
to work on that code base because what they're saying is that no, we rather work
Mm-hmm.
on Objective C or Swift for iOS and Kotlin
Of course.
for you know Android, and so that that way at least we can engineer the
But I
best
think,
apps. And now they do have really
but
good
I think
apps.
this was a
Uh, what would
Yeah,
you
yeah.
say?
I think
Yeah.
this was an attempt of fixing an actual problem with a wrong anti-systemic solution. So
Yeah.
this
Yeah.
is what I was trying to get at, right? That a lot of times problems, are not technology problems; they're people problems, right? Collaboration problems. So,
Yeah.
an example:
Yeah.
why do people go for multi-platform or for this whatever C++ approach? Right? It sounds a bit weird to me. But the point is, probably they started with native apps And then the thing is, they were diverging, right? And so there were bugs in
Yeah.
Android, there weren't in iOS, and then they couldn't scale, and there was parallel work which didn't obviously finish at the same time, and it was a mess, right? And so they said, hey, why don't we just create a single team, single code base, and we all write C++, right? And because they can't seem to, this is the thing, most companies, they can't seem to fathom the fact that people can actually cope with things, right? And a much better way of solving this problem would have been to create a single team, which is still wrong because it's a functional team, but in that world, you can still have created a functional team of just Android and iOS engineers and made them all co-responsible of both code bases. And I would have
Right.
like self-organized to learn both and work together so that they could ship together and stuff like that, right? Without blaming each other and the whole thing. And instead, engineers, this is another problem that I see is that typically engineers are promoted into management and often executive roles based on their engineering skills, and then these things happen. Because instead of thinking, hey, this is a people problem, they think, oh, hey, if there's a cool way of, deriving Android and iOS from C++, that would fix it, right? And well,
So, what would you say? Okay, I have an interesting question, slightly diverging from the current topic.
sure, no worries.
Um, where do you see AI is coming into software? Now, you're probably aware of GitHub Co-pilot,
Of course, yeah.
which is pretty interesting.
Mhm.
Some people have good opinions about it. Some people have bad. Now, the thing is that whatever it is, it's going to get better. So just for the just to mention what it does, it's basically you can write a line where give me a HTML page with a login screen, and somehow it will go and give you the right code with a login screen, probably some two fields and a button, username, password, and everything, HTML, all sorted. The thing is that that's pretty interesting. Now, it's going to get better. However, what I'm really interested to see is writing code is I can see it will get better, but it's about debugging code. Do you see AI can debug code, and would AI be able to debug code faster and more efficiently and get to the problem that, oh, this field is giving an error because no error handling was put in, right? This API crashed because something has not been some Kafka topics are missing or something, right? Something like that. What do you say about that?
Yeah, I mean, it's an interesting thing. I mean, in this sense, I can definitely see AI being potentially very useful, right? So as you said, there's a debugging, supporting tool. Also, like in terms of the IDE. So sometimes one of the things that I would love to see, and obviously, I mean, it's a big ask in general, but one of the things that AI could definitely help doing is that if I'm doing some things manually and AI picks up a pattern of what I'm trying to achieve, it might try to complete it for me, right? And say, hey, I see you're doing this. Do you want me to help you with that? Yes. And it would just, sometimes these kind of refactorings are not easy to refactor, to basically apply using the ID itself, because it might be a little bit different and all over the place. And so this is definitely like something interesting,
Yeah.
right? The debugging thing, definitely. But in general, my feelings about Copilot, some people be like, oh, developers will get out of job or stuff like that. It's all very naive for a couple of reasons, right? And so first of all, I don't think the job of software engineers to make things work. I think that's not even close to be enough, right? And this is very unfortunate because in a lot of companies, once again, they don't seem to appreciate that, right? And if I write a piece of software, the fact that it actually works is I mean, of course, it should work, right? And just Google whatever today. So, at the end of the day, you don't even need Copilot in theory. You can just Google things and eventually things will work. So this just shorten that cycle, perhaps. But the point is, there's a couple of aspects here. One is the job of a professional software developer is to write a code base and contribute to a code base that multiple people maintain, right? And this is an important point. The point is, when you work for yourself and you're not a professional, everything's easy because the entire program is in your head, at least for a while. Then after a few months, it'll be funny. And you don't have to change it that often. And if you break it, doesn't matter. and no other people would need to understand it and maintain it, right? And no people modifies it concurrently, so you always know how everything works. Now, in a world where you have 200 people maintaining a code base, a little bit different. And also, if you write a project for yourself, this stuff typically has no users, very easy to change. Now, suddenly, if you need to structure the next 10 years of a company's performance based on a code base, well, that's a little bit different, right? Because what you're optimizing is not the speed of writing things, it's the speed of changing the requirements later on, right? And so there are some writing techniques, if you go into object-oriented programming and if you structure things with test-driven development and domain-driven design, that basically help developers keep the cost of changing an existing code base low through the following years, right? And you see a lot of companies that actually implode because they don't take care of this, right? And they're like, oh, we hack things together, it's an MVP, and then they call it version 1, and then 3 years later they crash because their speed of change is so low that either competitors crash them or they end up killing themselves with tech debt, right? And it's a very different thing. So do I think that Copilot can help? Probably not in that sense, right? It can probably figure out, given a function, what to speed out, and sometimes might even be correct. But fundamentally, the fun thing is that it will never really be able to work because what readable code means depends on the team, right? There is no correct answer here.
Yeah,
and so the
go ahead. It basically there's a really interesting meme that comes to my mind, where not meme but more like a post I saw. Someone basically wrote, if all the answers are on Stack Overflow, then why do we need to hire engineers? Can't I just copy the code from Stack Overflow and engineer something, right? That's exactly what we're saying with GitHub Co-pilot. And yeah, I agree. It's so there is one thing, which is that engineers writing code that can be easily changed, easily readable, easily deployable, as well as I would say evolvable. Like it goes and becomes something much more complex, and it's still maintainable. And all going forward with that, there is that aspect of making sure. One thing is that as something becomes more and more complex, it becomes really slow to maintain, and keeping the speed of evolving faster while it becomes more complex is quite something else. So yeah, I agree with that. I can see that with Copilot, it could definitely give you the right function. It could give you at least the best thing it can do, which I would say you can use it for, is the syntax, right? It'll give you the right syntax, and it might even give you the latest syntax, because sometimes the syntax is changing. And the thing is that but you still need an engineer to figure out the whole bigger picture of that. And the other bit is that the debugging, it could actually help in the debugging side. Take the API, paste it in Postman. Maybe there might be like an API version of the Postman where you test the API in the API Postman API, and then test that, and then go to the next stages and see whether it's having a good impact or not. That's fine. One thing I'm just wondering is that what else would you say where say AI could be useful? I agree with another point you made, but it's not going to replace any software engineers. That's just true.
Yeah, I mean, thinking about it, I think definitely, Copilot, as much as I'm not a fan, it goes in the right direction, which is, I think, that enhancing a developer while they're working is actually the right path. And so, in my mind, once again, AI-driven IDs could become a big thing going forward. And as an example, also some tasks that are fairly predictable in terms of patterns could be driven by AI. So as an example, if I have a library and I need to convert it from, well, maybe that's not that easy, from a language to another, that could work. Or, if I have a set of interfaces and I need to do client SDKs derivation, it could work today, but it's a lot of work. That could also somehow be, done by AI. But yeah, basically like everything that enhances what a developer wants to do and removes things that are, a chore or
Yeah, that
not
is true.
particularly straightforward. Yeah.
Just the last question on Agile. Would you say what would you say about Agile? Where suppose for the requirements gathering part, when you're trying to discover a new project scoping out, or maybe you're not scoping out, but maybe just trying to discover a problem, and you are in that discussion phase of, okay, here's something new. Would you say that, suppose that was in the waterfalls way, you did that first, you gathered the requirements first, and then you moved into Agile, Kanban, or Scrum. What do you say about that?
Uh, well, I mean, I'm not so Kanban and Scrum. I mean, I'm hardly a fan of either. But the thing is, it's still because they are pre-CAN frameworks, and pre-CAN frameworks don't work well with reality. So the entire point of Agile is to try some. So basically, if you're in a like complex scenario, what you want to do is try a little bit, see how it goes, and adapt, right? And if you got like fixed responses, it ain't gonna work that well. So as an example, we work with ensemble programming, right? And so typically I'm working with like 3, 4 people on the same laptop, and we constantly rotate and collaborate all around. Do I need stand-ups? It's kind of ridiculous. I really don't. Why would I do it? It just doesn't add anything, right? We don't even use Jira. We're all co-located. Don't need that, right? And Kanban's the same. I mean, it's much better than Scrum in my mind, but still, it's limited. Why do I have to stick to these specific things and just do whatever I want, right? And in particular, when companies adopt this Scrum and Kanban and so on, especially when they mandate it across different teams, and we all start the sprint on Monday. I mean, it's all very funny to me. But the point is, what they're doing is they pretend to adopt these agile methodologies without actually wanting to change anything, right? Because the entire point of agility is that the teams should be in charge of defining their own process and tools, right? And so that's the real power. That power is what grants the benefits, not a specific framework, right? And and so things, it depends on the team, right? Depending on the team members and their experiences, different processes might be better for those teams, even working on the same code basis, right? And, some teams maybe they might be fully remote, and maybe what works for them is different. Some teams are co-located, and there's all sorts. And obviously, with waterfall, it's kind of very funny because people plan and plan and plan, and obviously, as soon as the plan gets in contact with reality, everything crashes and burns. And so you want to basically shorten, once again, that feedback loop as much as possible. And you want to say, hey, let me try something, see if I'm getting in the right direction. If I am, I'm going to continue on it. Otherwise, I'm going to step back and try something else, right? And I'm a big fan of the idea of working skeletons, which really help if you're bootstrapping a project from scratch, which is instead of, when you build a project, you could build it sequentially, where you build really well the first thing and then really well the second thing and so on. Or you could build incrementally, where you build one tiny amount of functionality throughout, and then you add flesh on the working skeleton, right? I think that's really important because basically it allows you for faster feedback because you get in production much quicker, and it allows you to validate all your theories. So as an example, if I'm building a platform that, I don't know, supports multiple countries and multiple cloud providers, right? Can I make it work this way? And if I can, then I can create the login page with all perfect details, but there are no unknown unknowns there, right? So it's pointless for me to start from that because I might discover 6 months down the line that my plan doesn't work, and then I would have just wasted time, right?
Yeah, that's quite interesting. Yeah, especially with beginning with something which is not the unknown and unknown of unknowns. Um, yeah, the one thing I always say wherever I go and work, or whichever sort of person I talk to when it comes to agile, in teams when they're trying to implement agile or trying to work in finding ways of working, is that the whole idea of Agile is that you pick and choose
Mhm.
what works for you, right? What gives you power, what basically makes the needle move forward, basically. So yeah, that's what I would say. And sometimes I agree that you could be planning, and then you actually go and do something, and then you realize, oh, actually, it doesn't.
Yeah.
It's not. The world is not just paper and
Mm.
pencil.
Yeah, yeah, exactly. And
Um,
everything in the system, everything is interconnected. Right? And so as an example, if you're doing the multi-cloud, multi-region thing, you cannot and really shouldn't plan and build the multi-region thing and then do the multi-cloud thing or the other way around. Because
mm,
the way the multi-cloud part needs to work when it includes multi-region will change how multi-cloud itself is designed and the other way around, right? So those two parts are interdependent. They need to coexist. And
yeah,
it's not given at all that if you build a perfect multi-cloud thing and a perfect multi-region thing, they will work together.
yeah. Yeah, that's multi-cloud and multi-region.
Yeah.
That's extremely complex,
Mhm.
and to get it to work properly, there has to be a way of I guess trialing and
Mhm.
proof of concepts,
Yeah,
and
exactly.
then yeah, I agree with that. Cool. That brings us to the end of the podcast. Thank you for being on the show,
Oh, it was a
and
great pleasure. Thanks for inviting me.
thank you. And we'll see you guys next time.